Hi, and welcome to today's math video on comparing fractions. We've been playing a game with our fractions, and we'll do that game at the end of today's video. But I want to share with you the 6 ways that we've been comparing fractions, and I'm wondering if you have any additional strategies. If you do, please let us know in the comment section so that we can all learn together. But when I was taught to compare fractions, it was always the same algorithm. Change everything to a common denominator and then you can compare fractions. Well, hallelujah, we have moved beyond that. Now we can just think about it. Think, what is 1/6 compared to 2/3, 1 out of 6, 2 out of 3? They can just think about it. They can use manipulatives, my favorite. They can compare by changing the fractions to decimals. We know that the decimal section comes later in the textbook. And this year I'm doing something different. I am starting with that right on day 1. I started teaching that decimals are just like fractions. They're a piece of a number, and it worked really well because it was Pi Day time, and I was able to show them, 3.14 is a very small number because of all those other digits are just pieces of numbers, they're fractions, and so they really understood that. And so my students now are taking their calculators and they are very confident in changing a fraction to a decimal. Now, do they have a deep understanding of decimals? No, they don't. But that's not my goal right now. Right now, I see myself as being a scaffolder. I am priming them for decimals so that when it comes up in a few weeks, they'll be even better then to go deeper in their understanding. So we have manipulatives, we have decimals, we have thinking about it. We have the butterfly method. That's a bit controversial right now in Mrs. Matsuda's class, isn't it? Because the teacher does not fully yet understand why that works. And that leads to the question, if we don't understand why something works, should we actually be teaching it? Did I have any business teaching that to my class when I didn't even understand why it didn't work? Truthfully, I think I was hoping nobody would ask because I didn't have the answer to why it works. I just kind of hoped they would say, okay, and do it. What would Joe Bowler say? It's something to think about. But I do hope that I will soon fully understand it. Wonderful Stanley is coming to my class on Monday to explain it to Hannah and the rest of her classmates. We also have the number line can be used to compare fractions. I did a video on this last week. If you're looking at this and not knowing what this is all about, it's the number line video. And then we've just moved into mixed numbers. So now we are learning how to change improper fractions to mixed numbers, and then they can learn how to compare fractions that way. So 6 different strategies for comparing fractions, none of which involve changing them to common denominators. Are there more? Are there more strategies? Well, this is how we've been practicing it. Now, we know how to play multiplication, addition, and subtraction war. Well, this is just fraction war. And where did I find this idea? On Pinterest. I can learn how to make a charcuterie board and math strategies all at one site. Thank you, Pinterest. But this can be played in groups of 2s and 3s, and I force them. And I don't have to force them. They love doing it, creating the manipulatives for each fraction. So let's look at this first one, 12/9. Now, we don't have ninths. My students keep wondering, why did they not make ninths, sevenths, and 11ths when they started saying, well, there are fifths and sevenths, fifths and thirds. There are fifths and thirds. Why didn't you make the other ones? They were trying to draw conclusions, and honestly, I don't know why they didn't make those. It makes no sense to me at all, but these are good questions. I then tell them, if there isn't something for this denominator, do something that's close to it, like maybe, this is pretty close to the 8ths, or the 10ths. I seem to have lost my 8ths. I don't even, here they are. They're over here. So they have to have more than one set, which is essential, and when they play together, they do have more than one set. but they have to get 12 eighths, and then they can see, they hold it up to the 1. We'll fake it right here and pretend that's 12 eighths, and they can see, yes, this is greater than 1, which is what an improper fraction is, isn't it? And then we have 11 out of 11. We don't have 11 out of 11, but we can use 12s, 12 out of 12. I'm going to disclose something to you right now that maybe I shouldn't. It's a bit embarrassing, but I was in my 20s before I realized why 11 over 11 is 1. I just learned the algorithm. 10 over 10 is 1. 11 over 11 is 1. I never understood why until I became a teacher and I got manipulatives. And I said, oh my goodness, 4 out of 4 is quite literally 1. Why didn't I understand that until I was in my 20s? Because I had never been taught with manipulatives. So I am definitely team manipulatives, and I bet you are too. So whoever has the biggest fraction wins that one. Now it can also be played with 3 people, and this is what it would look like with this one. And I make them write the line here. Do you teach your students that this line also means divide? I find 4th graders are very surprised to learn that this line means divide. But now we have 2 out of 3, 2/3, which is going to be right here. But they can see that this is less than 1, this is 1, oh, there it went, and then this one is greater than 1. So what I'm thinking is for this week, I need a game where they just practice greater than 1, 1, and less than 1. And if I can't find one, I'll make one. And it probably won't be an earth-shaking game, you know, but it will be an important game for them to practice that concept. And then just think whoever has the biggest fraction in this situation gets all six cards. So this is called Fraction War, and you can play it tomorrow, even if you don't have this set of manipulatives. You just use whatever you have. Maybe you have those old circle sets. Boy, those sure could scatter in 100 places, couldn't they? Or maybe you're going on Teachers Pay Teachers and downloading the manipulatives that you can have your students color and then laminate, and then you have the manipulatives. It doesn't have to be these, although these are my favorites right now. But give this a try. I hope you have seen something today that you can use in your classroom tomorrow to help our students to better understand fractions so that your students won't go through life not knowing why 4 over 4 is 1. If any of you didn't understand that, would you let me know so I don't feel alone? I can't possibly be the only person who never understood why that algorithm worked. So let me know if you had any of those. How about, do you have any misconceptions about fractions that you'd be willing to share, or misconceptions that your students have that you'd be willing to share? Because we certainly can learn from each other together. And I can't wait till we're together again next week. Goodbye.